Hello, my name is Robin Burke, and I am a professor and the chair of the Department of Information Science at the University of Colorado Boulder. And I'm here to talk to you a little bit about my research and let you know a little bit about what we do and how that relates to data science. So my particular research area is in what is called recommender systems. Recommender systems are applications that provide personalized access to information or items, typically involving the ranking of items by preferences inferred from users. Now, these recommender systems are a big part of your everyday online experience. E-commerce sites like Amazon or booking.com, social media sites like Facebook or TikTok, music like Spotify or Pandora. All of these kinds of applications have a strong element of personalization and recommendation as part of what they provide. And actually many of these applications have multiple recommender systems embedded within them. Recommender systems are very data intensive systems. So they involve a lot of the things that you will learn in a data science program. Think about it, these sites have millions of users, they might have millions of items. Users interacting with those systems produce millions of interactions every day. And what you need to do in order to build a recommender system is to be able to distill patterns from those profiles and from the data that's associated with items. Think of the text in every tweet or in people's Facebook posts and the images there. And we need to use those profiles to understand what users are going to be interested in and what things they're not interested in. And then we need to build systems that will produce these kind of feeds or ranked lists of for interaction. We need to produce those things very quickly. When you click on something, we may need to update those preferences and update the answers that you get to reflect the user's changing needs. So these are very complex and sophisticated data and very data intensive applications, some of the most challenging applications that are out there right now. What I look at in particular in my recent research has to do with algorithmic fairness. And you may have heard something about this, this topic before. This is a body of research looking at how in machine learning systems, biases in the input or sometimes in the algorithms themselves can produce biases in the output. And these kinds of biases can have self-reinforcing effects so that choices you make now can cause increased unfairness in the future. And those effects kind of cycle around and build on each other. So there are plenty of examples in healthcare, in credit, in the criminal justice system, in the provision of public assistance, et cetera. So this area has been studied for a while. And one part of my work has been to extend these ideas towards recommender systems. So the first question you might think about is, well, what does it mean for recommendations to be fair? Our basic idea, here's the quote from Aristotle about fairness: equals should be treated equally and unequals unequally. We have the sense in recommender systems, everybody is different, they're entitled to different preferences, so they should get different results. But some kinds of recommendation outcomes can be unfair. And in fact, here's an example from the news in 2018. The system in Facebook that was recommending job ads to users was providing very different kinds of ads to male and female users. And that was actually considered to be in violation of equal opportunity protections in employment. We also know that recommendation can produce other kinds of undesirable outcomes, reinforcing users' biases, reinforcing sort of general societal biases that are found in data. And there have been a number of recent scholars that have written about these kinds of effects, and they're things that we want to avoid. And so the question is, how can we design better recommender systems, try to counter some of these problems as we understand them? This is a research area that's about 5 years old or so, basically trying to counter biases in the input to produce better, more societally beneficial outcomes. Now, an important aspect of this is that it does kind of run counter to what we think of as the goal of recommender systems to be attuned to the needs of users. Users might not care that the system is fair. They might actually even prefer that it be unfair, as long as it's unfair in their favor, which is Calvin's point here. He knows the world's not fair, but he just wishes that it was unfair in his favor sometimes. So this means that fairness is not totally compatible with personalization, which is kind of how we have thought about recommender systems for a long time. So if we think about personalization as making computer systems work better for the individuals who are the end users, we're not looking at a larger audience. And if we are interested in fairness, that's exactly what we have to do, and think about how the results for one individual might affect another individual or another group of individuals. So this is a challenging thing to our user-centered view of personalized systems, and makes us think about the other potential stakeholders in the system and how an organization might incorporate different, fairness objectives that come from different sources, stakeholders that may come from a variety of places, either from organizational mission or business objectives, or even legal constraints, as we saw in the Facebook case. So this thinking brings us to an idea that I call multi-stakeholder recommendation. This idea that when you want to make recommendations, you actually want to think about multiple affected groups or multiple affected individuals. And there could be a lot of stakeholders, but the sort of key ones we think of as the provider, the individuals that produce items, like musical artists, for example, or authors, that would eventually become recommended. And then there's the platform, so Spotify or Amazon.com, the site where those recommendations are going to happen. And then finally, the consumer that is getting those recommendations and deciding to act on them. And there may be concerns at all these different levels about how the system's results affects the different stakeholders, including fairness concerns. So we think about this in a couple of different ways. We can identify consumer fairness, so C fairness, where what matters is, are we fair to the individuals who are getting the recommendations? Job seekers, for example, male job seekers should not get better recommendations than female. And as we saw in the Facebook case, there may actually be a legal requirement to do that. But there might also be provider fairness, where we care about fairness relative to the items being recommended. And the reason why we care about that is because there are individuals standing behind those items. In the case of books, authors, for example, we might want to make sure that male and female authors are treated equitably in terms of how their books are recommended, and that can eventually lead to sales or reputational benefits that we don't want them to be unequally shared across individuals. So these are the kinds of problems that I work on. And one thing we have found, different kinds of fairness problems, like the ones I've outlined here, they require different measures to detect unfairness, different kinds of algorithmic approaches to enhance fairness. There's a lot of interesting problems in this area. And we're just starting to see some of the organizations out there start to deploy recommender systems that use these kinds of fairness considerations. And I think we'll see more of that in the future. So thanks for your time. So my email address is there, and I'll move out of the way so you can scan the QR code, which is the website for my research group, which is that Recommender Systems Lab. So good talking to you, and enjoy the rest of your course.